There we go. Hi, everyone. Somehow a Google Meet link snuck up on our calendar invite again, maybe when I move the meeting around. So hopefully a bunch of folks aren't sitting over there.
I feel like it's that scene from Mean Girls. Stop trying to make fetch happen.
Yeah.
As the Google representative on this call, I'll just say, I feel your pain. There's nobody on the meet, so it's fine. So.
All right, thanks, Michael.
So the Google, the calendar invite with the Google Meet should have been deleted from the public calendar. So if you have a ghost Google Meet cal invite on your personal calendars, delete that cal invite.
I think I was just looking at the community calendar.
Yeah, I'm looking the same.
And I just took off the meet link there. I don't think Ghost is in my calendar, but it's possible. Can someone fix the calendar issue? Do we need a foundation?
Oh, sure, Kim. Solving calendaring. You know, let's put world peace, hunger, software supply chain security. But first, we're going to fix calendaring. That's funny.
You know, Kim, I'm just jumping in, but Jory is back. She knows how to do all sorts of cool calendar things.
Perfect.
So I don't know what the problem is, but if you, I would just tell her, shoot her an email. I will post your address.
She was just talking, Michael, I think maybe right before you joined.
Wait, does this mean she can also handle world peace?
No.
Oh, come on, Jory, if you can handle the calendar issues, world peace is easy.
I know. I'm thinking you gotta update your resume, girl, because
Yeah.
All right, I'm talking you up. Sorry, Jory.
High expectations. Thanks, David.
You know, here's the problem. You keep meeting them.
Well, that's so nice.
Smooth.
I wasn't trying for smooth, but I'll take it.
He's just butting you up. He has a horrible favor to ask. He's going to ask you to fix his calendar, which is a complete nightmare.
oh, Michael has seen this play before.
Exactly.
Yeah, there are some things that are too hard. You know, harder than world peace, for example. That's definitely one of them.
Multi-person meeting scheduling across organizations. No, we'll not touch it.
All right.
Let's get started. Welcome, everyone. So it seems like all you folks found the right meeting and the right time due to our time change in the US. We also moved this to be the alternating weeks, and I think the alternating day, but you all know that because you're here. We have a few things on the agenda today. So I'm not sure how to time box some of these, but I think maybe they will all stay within time. But anyway, let's kick it off. Mark's going to talk about the SLSA proposal process. Mark, I don't know if you want to screen share or you just want me to open this on my screen, just holler.
That's fine. I don't think we need to spend a lot of time on it. I just wanted to mention that there's now a proposal for the proposal process. I created the first proposal being the creation of the process, mostly as an example to see if it works. Joshua reviewed it so far, but it would be great if there was any other feedback, whether it's just a +1 or if you have anything constructive to add. I just wanted to throw that out there just to get more eyeballs on it.
Okay. Do you want to, sorry if you cover this in another meeting, just like the 20-second TLDR, like how you want, this is for big changes to this also spec and a process that folks should follow, or we should try.
Yeah. So if you click in the files changed thing, you could then view that file. Well, if you click the little dot menu and hit the view file in the upper right, it's the addition of the proposing changes. So we'll still use GitHub issue. The proposal is that we still use GitHub issues to describe everything. If there is an issue where it's unwieldy to use a GitHub issue, mostly for larger things. Then we can create a proposal document in this other repo, which is like basically like a design document. And that is allows us to track. If you go to pull requests in that other tab, you could see the very first one. Right there. And again, under the files changed, you could view the, you could actually view the initial document. And so basically just a recommended format to lay out what is the problem you're trying to solve, what is a prior art, what are you proposing, what is the rationale for doing that, as a standard way of getting agreement on kind of more thorny, difficult issues. For one particular thing that we had talked about in the past was expanding SLSA to, like, possibly expanding SLSA to cover more than just integrity. This would be an example, that would be an example of something that should be a proposal, because there's a lot of pros and cons and things to weigh, and we can't really capture that in a GitHub issue.
Cool. Awesome, thank you, Mark. Yeah, for folks that have feedback, feel free to check out the issue and leave Mark some comments. All right, next we have Azra and Lauren to talk about non-falsifiable SLSA provenance. And it looks like you guys probably want to take over the screen.
Hey, yeah, let me try screen sharing. Oops, sorry, I forget how to do this with Zoom all the time. Okay. Can you see my screen?
Yep.
Okay, and then if I do this, okay. Cool. I feel like I thought there was a way I could see everyone, but maybe there's not.
It's weird. Is there a little panel on the, like, it usually takes over my entire screen and then I see like the pictures on the, in a vertical. It's fine. I will help you if people ask questions or raise their hands.
Okay, awesome. Sorry about that. I really don't know how to see the chat box or anything, but yeah, feel free. If someone does have a question, just interrupt me and like ask the question. Okay. So Laurent and I have been working on this like proposal or design and proof of concept as well for particular implementations around achieving like a high level of SLSA. So in this case, SLSA 3 or 4, and how that would happen using kind of like native open source tooling. So we're really just using GitHub Reusable Workflows, which is this like kind of new feature launched, I think, last fall, and GitHub OIDC, which is also a relatively new feature. So with both of these features, we're going to kind of walk through how to get to SLSA 3, and then kind of talk about also a little bit of, you know, how to get to SLSA 4 with the same sort of technique. And so the motivation here, like I said before, is that we kind of want this upgrade path to SLSA 3 for GitHub native projects, and we don't really want to introduce new tooling to them. So if they're already relying on GitHub Actions for CI/CD, then they can kind of like, you know, sort of use these solutions and use our like demo POC and like enhancements around that to kind of get to SLSA 3 pretty easily, kind of with like no additional work, and then maybe also for SLSA 4 once we kind of work through all of that. And then the other motivation here is that like a lot of package managers have GitHub Actions that allow publishing, and integrating with a SLSA 3 provenance generator, like we're going to show you, would be an awesome way to get integrations with package managers. So yeah, that's kind of the high level here. So I'm kind of going to just jump right into like what reusable workflows give you and how our solution kind of builds off of that. And also, yeah, just I figured this audience is like relatively like familiar with the SLSA 3 requirements, although like I always have questions about them, and I'm sure like I'm not the only one. But the build requirements are here, the provenance requirements are here. Later on, I'll kind of like go through each one of them and kind of demonstrate why our solution fits all these boxes. But the main thing here is that non-falsifiability for L3 is achieved with this sort of like reusable workflow and OIDC token generation. Yeah. Okay. So on GitHub reusable workflows, so a reusable workflow is basically, it's similar to an action. It gets called kind of like an action, but it is basically a mechanism that GitHub released where you can call a workflow defined in a separate repository from the caller workflow. So for example, I can publish a reusable workflow on my own repository, and then each of my individual, like let's say project repositories can go and call into that reusable workflow. So the way that it works, like in the sort of like from the caller's perspective, again, you're just gonna, the way that you might call an action by like a uses invocation, you would also say like uses blah, 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 reusable workflow. So path to reusable workflow at a particular reference. So what we're going to do in our solution is construct a reusable workflow that acts as our trusted builder here. And the reason why this works really nicely is that because of GitHub's job isolation and because of the isolation that reusable workflows give you from the caller repository, we can kind of inherit, we can kind of like achieve those build isolation and user isolation that SLSA requires. So the first thing is that the user interference, so between the caller and the calling workflow, like nothing can really be propagated besides defined input parameters. So this means environment variables, defaults, services, other steps, other procedures going on in the caller workflow, so in the user workflow, don't get propagated inside this reusable workflow. And then the second thing is within this reusable workflow, we can define jobs. So like just how like normal GitHub actions have jobs, a reusable workflow is just, you know, structured as a typical workflow. But each of these jobs has isolation between them. So each job runs in an isolated VM. And so within this reusable workflow, we can define steps like a build process, and we can define steps like a provenance process, and those can be isolated from each other. So then we get that build process isolation from the provenance. That is kind of the main difference between why we're using a reusable workflow here rather than an action. So our reusable workflow gives us individual job steps that can be isolated from each other. So that is a super cool feature.
Quick question, if you don't mind. I'm not familiar with reusable workflows. I am familiar with GitHub Actions. Is it hard to convert a GitHub action to a reusable workflow?
That's a good question. So within, let's suppose that you are a project maintainer who has a build workflow, right? So you might define like a series of jobs. Within that, you can define a job that calls into the reusable workflow. So it's pretty much like, it's as hard as adopting an action.
Thanks.
Does that make sense?
Yes.
Awesome. So in our world here, like in our SLSA POC world, what we're doing is we are going to be defining these trusted reusable workflows that do these SLSA procedures, and other people, like for example, like other people can adopt those workflows to, like, let's say create provenance or run a build and create provenance. Likewise, like package managers could adopt this solution to say like, okay, I'm going to define like me as PyPy or me as whatever can decide to publish a reusable workflow that would create provenance for their project users. So right, I kind of went over this. Within the reusable workflow, each job is isolated like a typical GitHub workflow, which means that we can isolate a job step like provenance generation from a job step that might run a build. Likewise, we do acknowledge that like you have to be passing some data between those jobs. For example, the output of the build process might be your artifact or your artifact hash, right? So that data can be passed into the provenance build step by namespaced job outputs. So here we are kind of trusting GitHub. Obviously, we're trusting GitHub in, you know, running the code that we define in our reusable workflows. We're trusting GitHub to do a variety of different things later on as well. But we also are trusting GitHub that they're not man in the middling these namespace outputs. That's kind of like a further next step thing over here. If you have any ideas about, like, you know, getting GitHub to sign off or verify that data, that would be interesting. But for now, what we do is we kind of hash checksum the authenticity between the job processes. Does that make sense? I will just show a picture and then you can marinate on any other questions here about reusable workflows. So out here on the blue calling workflow, so that's your project maintainer who's building project foo. And then what they can do in our demo POC, for example, which works with Golang, they can define in their source repository a SLSA release or YAML. So this might look exactly like a Go release or YAML. Then they will call into the reusable workflow just like an action. So they'll invoke this reusable workflow given these defined input parameters. So that's the only thing that can really pass into this trusted builder, which we define to be like a Go version or some like environment variables that need to be generated at build time, for example, like a Git version. So within this trusted builder, reusable workflow, we have isolation beyond besides this input parameters. And inside this trusted builder, we might have individual steps like a build step or a provenance generation step. Our POC does a build and a provenance generation and sign step. But you could also imagine if your calling workflow were to do the build process, then you could define a more generic trusted builder that just generates provenance given an artifact hash. And this kind of came up, Mark gave us this idea, which would be awesome to do. And I just kind of have to go and do it. But that means that it would be applicable to any kind of build process. And then out comes like your binary and your signed provenance from your trusted builder in our POC. So if you click on the link, I shared this slide deck with SLSA discussion, but if you click on this link to the provenance over here, you'll also see where our trusted builder is defined. Any questions? I'm just kind of setting the stage of like what a reusable workflow is. All right, so now I'm going to go into the second piece of the puzzle here, which is like, how do we do authentication and signing? So like I said, we're using like basically two GitHub features. The first is reusable workflows and the second is OIDC. Recently GitHub added support for OIDC. And so what kind of happens is every single time you run a GitHub workflow, you are provisioned by GitHub a unique bearer token. And so what you could do is you could make a request to GitHub's OIDC provider, given that bearer token, and then receive back an OIDC identity token. And that identity token will attest to basically your workflow identity, which would contain the calling repository and the caller repository. So it would identify this trusted builder, plus it would also identify the workflow that called into the trusted builder in the case of a reusable workflow, which is awesome for us. It also identifies like the commit SHA that it was called from, identifies the trigger, it identifies the actor if it was a workflow dispatch, and so on. So it identifies basically like a set of features that we are going to use to sort of identify what this trusted builder is given a signed provenance. And so then what we do with that OIDC ID token is that we go and talk to FullCO, which is SafeStore's root CA that generates code signing certificates based on OIDC tokens. So FullCO will go and verify that OIDC ID token and a challenge after a challenge that attests to a key generated inside this trusted builder, and then spit back to you a signing certificate if that identity looks correct. So basically FullCO is giving you a certificate or like a little attestation saying, hey, yes, your ID token was verified and you truly own whatever signing key you wanted to request from. I really should have added a signing key in this diagram, and I'm sorry about that. But what this kind of gives us is a mechanism to sign an artifact and tie it with the builder identity. So just as an example, this is what the identity looks like, essentially. Well, it's not quite the identity returned in the certificate, but it's the identity token that GitHub provides you. And that is sent to FullCO. So I just want to point out like a couple things here. And also I will take questions after this slide as well. So I want to point out this job workflow ref, which is 5th from the bottom. That is the identity of the reusable workflow. So I think in their example, they're using Octo automation here. This would be like your trusted builder here. And then if you look up to repository, So that is the like 7th line or so from the top of the second of the claims over here. That is the calling workflow. So that might be the original user workflow that called into this trusted workflow. So it's really nice that we have both of these things. We have some refs for where it was called from. I think there should also be a commit SHA, right? There's a SHA there. So yeah, this is our main leverage here for identifying the trusted builder. Any questions here?
How do I get the Okta automation, the workflows commit SHA? Does it come with the, I can't see the tail end. Does it have the SHA, the tail end of that? Sorry, I can't see that.
The SHA of the, what did you say?
The job workflow ref.
The workflow ref.
Okay, so the workflow ref will contain like org repository path to workflow, and then like the ref will just be a ref to like main or something here. So you'd have to go and pull in
Sorry, I'm going to ask a question. So today main could be something, and tomorrow main could be something else. So how do I know what was passed yesterday or today? Like, just trying to understand.
Yeah, I think that the 6th line, this SHA over here, sorry, I can't point to it, but the 6th claim under above repository, I think that's the SHA for repository. So I think that might be the SHA for the calling workflow. I actually think that you need to trust each of the main things. And actually, Laurent, can you double check me, or is base ref or head ref one of those? I totally understand your question, by the way. Like, I mean, you're saying like, yeah.
Can you hear me?
Yep.
Mm-hmm.
Yeah. So all the base ref, head ref, and SHA are from the calling workflow, so the project. So the job workflow ref is the only thing currently available to identify the builder.
Okay.
So we can, like, there's no additional information right now of what main is. We can, as the builder, we can put this information into the provenance because we know our own hash. But I think we want to get, better security, because I think what you're pointing out is what we're aware of is someone might, if you don't trust the maintainers of the project, they could create another branch or like a tag on another branch and say this is v2.1 or something. So today I think that's the limitation, and I guess we're going to talk to GitHub to see if they can add a bit more information.
That's what I was looking for.
Yeah, I think the concern here is that like potentially your trusted builder's code could be corrupt, right?
Yeah.
So yeah, again, we don't have like a reference to the commit here, and so we can't really do an additional verification to say like, okay, are we at a trusted ref of the reusable workflow? So right now we currently, I guess, have to trust the entire history and code of the trusted builder.
It's not even just a matter of trust, but also for debugging. I've used other systems which do keep track of this information, and it has been life-saving on more than one occasion to know exactly what version of the CI pipeline was in play.
Yeah, I think on that it might be worth. We had like sort of a list of questions to ask GitHub, and I wanted to kind of double check this was addressed in one of them. All right, any more questions?
Thanks.
And if you want, like, it would be helpful for me because I'm like, I forget everything. Like, if you wanted to put in a comment about that, that would like definitely remind me to follow up on that.
I can do that.
All right, so again, so back to this picture over here, the full CO issued cert populates information from the OIDC identity token into X509 extensions, and also populates the subject name URI with the job workflow ref that I just showed you. So looking at that, we have a bunch of extensions over here that are defined in like full CO's code, but you'll see the job workflow ref at the top over here, the calling repository in one of the OID extensions, and the calling repository is SHA as well. So that's there. And so kind of just to tie this all in together, what we're doing here is we are able to sort of identify this builder through this signing certificate and trace back the information that was given in that OIDC token. So we do have to trust the full COCA to verify the OIDC token. And like, I guess transparently, we have that. And then once we verify that, we know to trust the builder ID. And once we trust the builder ID, then we know what code was executed to generate the provenance, which means that we know our provenance was service generated. We know the provenance was populated correctly. And we know that the signing key was hopefully ephemeral because that was the code run in the workflow. And also, we kind of know it's ephemeral. We rely on GitHub's like job isolation also for ephemerality. So I guess there's like two caveats there, is that we generally are trusting GitHub, SigStore, and the trusted builders code.
That's fair enough.
Yeah. It's kind of like I mean, we kind of had some discussions around like, oh, given that we're trusting all these pieces and little bits of each of these, like we're trusting the job isolation, we're trusting the ephemerality, like are there ways that we could verify those types of properties? So those are stuff that kind of came up with like, oh, we should probably follow up with GitHub on how to expose that.
This actually leads to a question. Have you considered trying to write this down in terms of here's why we met all the criteria, all the SLSA criteria, and here's the things we're depending on?
Yeah, at the end of this slide deck, and also I think I linked in the notes, there's a design document which like outlines in a lot more detail of what the verification procedure is doing and what it relies on, as well as like the for example, we rely on like the jobs to be passing data between each other through the namespaced outputs. So all of that's kind of detailed in the design doc. And if you find that something is missing or not clear, please feel free to comment.
Oh, this is music to my ears. Specific question: have you looked at reproducibility? Being able to check if verify that the builds are reproducible, like running a workflow twice.
Oh, interesting. Okay, like manual reproducibility checks. That's
well, not no automated reproducibility checks.
Sorry, I mean like not just like take a reproducible Boolean and like populate that, but you mean like
actually
go and
verify it. Yeah, actually rerun the process and make sure you get get the same answers.
No, we haven't. Partly because that would be like an ecosystem dependent thing, and we just haven't explored that. But that's also a really good point. I guess like in our model here, it would be like we kind of modeled our demo POC and like minimal requirements around like, okay, if we were to introduce hermeticity or introduce reproducibility, we could go from there. And so I could imagine that like inside this reusable workflow, we could run the build process 2 times, attest that the workflow hashes or the output hashes match, and then proceed on.
Or run the whole workflow twice.
I think you would only really need to run the build process twice.
Yeah, fair.
Yep. And then from there, that could populate a reproducibility Boolean with like some certainty. We could say like reproducible with like, 2 invocations. That's awesome. That's a good idea. Any more questions before I move on to sort of the end-to-end verification flow? Okay, sorry, I can't see anyone. All right, so visually what's going on here is that like the client has a provenance and an artifact. So they have a signed provenance and an artifact output by this trusted builder. And the first step that they're going to do is they're going to go and retrieve the signing certificate. Right now, we are just like in our verification POC, we're directly querying Recore for the correct signing cert. But you could imagine if you wanted to reduce the latency of like querying Recore, you could also publish your signing certificate inside the trusted builder and upload to your GitHub artifacts, and then consumers could go use that for direct verification. So you could skip this first step if you wanted. But anyway, we're output this signing certificate. So the next step here is that we want to go and verify the signature on the provenance. So we're going to take in the certificate and take in the signed provenance, verify the signature there. That means that we can at least trust that the provenance wasn't tampered with. So that gives us data integrity. And sort of gives us authenticity. So then from there, we're going to verify the builder identity by extracting the subject name of the certificate. So once we verify the builder identity, so verifying it means let's go and check that this is a trusted reusable workflow. Once we have that, we can actually trust the contents of the provenance because we know that that signing cert could have only been generated by an OIDC token issued inside that trusted reusable workflow, assuming, of course, that we trust GitHub to provision the correct OIDC token and that we trust SigStore to issue and verify the signing certificate. So from there, we go and verify the provenance. So at that point, we trust that whatever our builder identity signed was actually authentic and non-falsifiable. So at that point, we can go and parse that provenance payload, ingest that artifact, and do whatever verification we need. So maybe we hash the artifact, verify that it matches the provenance. Maybe we do some other sort of provenance matching to say like, okay, the config source was something I trusted, and so on, according to whatever policy you have. So does the flow of that make sense? Cool. So again, just in steps over here, I'm not gonna, it's basically literally what I just said. But again, here we're verifying integrity and non-falsifiability, we're verifying authenticity, and then we trust that provenance payload. So then we can do our actual policy check. Some other, again, in more detail, so unpacking that SLSA 3 achievement. Some other key points here on that non-falsifiability here. So in addition to just testing the builder identity inside that certificate, which gives us trust in the workflow content and the provenance generated, we also like note that that ephemeral key is only accessible inside that trusted builder. So that's like pretty key point in the SLSA 3 requirement list, is that the user process and build process don't have any access to that signing key. And that's because that signing key is generated inside the provenance generation VM. So it's isolated from both the build process and also from the calling workflow, so from project maintainers. Does that make sense? Cool. And then like the build.
Sorry.
Yep, go ahead.
I see parameterless scripted GitHub workflow in source repository. If I have to pass environment variables, like how do you make it parameterless, or any of like any things for my like CGO, any of those things, whatever I want for the Golang, how do you achieve that?
Right. So I think this might be like my understanding of parameter list here is that even dynamic like flags can, as long as they are generated by some scripted workflow or some sort of scripted code, then that might suffice. So for example, like putting in the git commit in like a version information or something at build time is still considered parameterless, given that we are putting it into the source code. Okay. Feel free to like.
I disagree, but that's
okay.
Yeah.
In your case here though, like how would you even deal with like dynamic flags?
Yeah, that's why. So that's my question, as you're calling it parameterless. So that means we have crystal clear define which parameters are acceptable, which are not. That becomes a kind of a gray area as to, okay, for these things it's acceptable, for these things are not. So it's kind of hard.
Yeah, for what it's worth, we do only accept an allow list of parameters. Our code inside the trusted builder will go and check those, and it also will go and actually list out inside the provenance what the build command was, and also what the environment was. So hopefully it's at least traceable. And also the calling workflow is referenced from the commit SHA and the source repository inside the provenance. So you can go and check the calling workflows code. If you wanted to sort of truly lock that down, obviously you can still use this procedure and just not have any inputs into the trusted builder beyond something defined in source. So you could eliminate that if you wanted to.
Sure. Sounds good. Thanks.
So, yeah, also something I think we discussed is, you know, whether the build is parameterless or not. I think it depends what level of abstraction you look at. If you look at the compiler, then the arguments and the environment variables, you know, there are some parameters. But if you look at the builder, which is triggered by just you know, a GitHub trigger, then the only parameters is basically just like the trigger name and the trigger, you know, the event payload. And like Asra said, everything is in source code. So basically, from the builder's perspective, the only parameters are, you know, the GitHub payload, the GitHub event payload, And I think that's why we're arguing that this is parameterless. But also something I want to point out is this is actually, independent from the implementation that we have. So if people believe that this is not parameterless, then in essence, it means that SLSA has a problem because you cannot achieve it. And especially in Golang, you cannot achieve it because you need those environment variables and so on.
Right. And like the idea of this solution also doesn't require you to expose those if you didn't want to. So you could just, again, like reuse this sort of framework, I guess, for achieving SLSA 3 in GitHub with reusable workflows and OIDC and not expose any parameters. Or you could limit what triggers you allow. Yeah. All right. Just to like.
Can we put a pin in this, because I think that this issue about what parameterless means is broader than this specific implementation. It's pointing out a concern. So I don't know how to put a pin in that, but we're going to need to come back to that more broadly.
David, check out the chat. There's an issue that people are referencing that might contain the scope of the issue. Issue 278, looks like.
278, okay.
So,
thanks.
Like we probably pinned it.
Yeah,
okay.
Don't want to derail it, but I think that one of the things that was brought up in a couple of the GitHub issues is that seems to be like a split between either do we want to have a set of allowed parameters, because the intent of parameterless is we don't want to allow the scope to be so broad that it becomes impossible to reason about what's actually happening in your build. At the same time, right, so if we can limit that, that's a big thing. And so that leads to sort of two flows. One is, could you have an allow list of parameters, or do you just literally define your build such that every single thing is like, here's a build with these parameters, here's a different build type with these parameters, and so on.
Yeah, e.g. for like security keys and that sort of thing, e.g. for secrets.
Yeah, I think, to my mind, as long as the parameters can affect the IDs of the outputs, and so that any change to a parameter is also a change to the artifact that you produce, and hence the ID of the artifact that you produce. And you can bake those parameters into either the build script or details on the invocation. There's no way for anyone to kind of modify parameters and try and produce a bogus artifact.
I guess my claim is that, like, for some ecosystems that might not be possible if you have dynamic tags that are based on versions or commits. But agreed that it is, like, for example, like the parameters for your event trigger are not going to change your build if it's reproducible. So actually, yeah, I guess, I mean, it really depends, but regardless, whatever you just decide parameterless means, it's like likely achievable with this structure, unless you have like such a stringent requirement that even something like the trigger would change that.
Just to note, with the Python rebuilder work, a very common thing, as Nasser you just mentioned, was taking the tag tagging workflow, the release workflow, as the trigger to release. And so I think that's a very, very common sort of maybe non-parameter, a parameter propagation that definitely needs to be sort of handled and considered.
Yeah, right. So maybe it's more like, yeah, allow list of parameters that we are defining here. All right, and then verification in general, like we have in our demo POC, at least, again, we're given a binary and a provenance, and we even like expose some like expected like source repositories, which are kind of go in the realm of like policy here, and expected tag and branches. And as you can see in like the sort of command line output here, we go and fetch the recore transparency log entry that this was uploaded at, and print out some information based on the signing certificate and provenance for that particular artifact and provenance set. So just as like a quick appendix, this is like an example of some of the provenance that is generated from our demo POC for Go. So on the right here, you can see the actual build invocation. You can see the source repository. You can see the trigger. On the left, you can see parameters. You can see the digest SHA, etc. The trusted workflow as well in the builder ID. And then just from here on, like just kind of closing it out, if you have any more questions, feel free to jump in. But there's lots of places to go from here. We can generate like more generic actions like Mark had suggested about just generating provenance given an artifact hash. We could define package manager specific integrations with this type of workflow, more testing, paths to L4, and so on. Reproducibility, as was mentioned earlier. Yeah. Again, like if you have other comments or like want to talk offline, feel free to comment on the doc or like on the slides or something.
Yep. And I just added a comment to 278. Because I think
awesome, thank you. Yeah, and we have some references.
Oh, sorry. Just on the sort of future sort of gazing thing, what is your rough idea for how integration with a package manager would go?
Right. So for example, like PyPy exposes actions to publish. So you could also imagine that PyPy would handle a reusable workflow that did the build step for you before you invoked the publish. However, I guess like in the case of like, if we just scoped our reusable workflow to just do provenance, that would actually be a lot easier as well. So users could keep their own defined step, and then right before they do PyPy publish or npm publish, they could call into a reusable workflow to generate that provenance and send that with them. Does that make sense? So this isn't the case where someone already has like a CI action in GitHub that is publishing to their package repository.
Gotcha. I was actually envisioning this as sort of a tail sort of action on an existing workflow, but you're saying it would potentially be in the middle between like build and publish.
I suppose so, yeah. I guess we could also get direct integration with the publish step. And right. That way users don't even have to change their calling workflows.
Cool, thanks.
I think for that.
I mean, I think also for anything with package managers, I don't think right now there is a spec for a provenance. So if you want this to be part of package managers, we first need to agree on, where is the provenance going to be kept, because you want like pip install to actually check the provenance, or at least you want pip install to be aware of, provenance information. So I guess for this to really work, we have to work with package managers, and they have to kind of be willing to, to adopt SLSA provenance. Otherwise, no one is really going to check, or no one is going to know where to even fetch the provenance for a package. Yeah, that makes sense.
There's a new group with some of those folks. You could probably figure out where those discussions are happening and maybe see what they're thinking. All right, am I resharing? Cool. All right, Azra, this was awesome. I have a couple questions, but since we have a few more topics on the agenda today, maybe we'll take any more questions offline, but this is an awesome demo and I'm excited to see where this goes. Cool. So next we have a discussion question from Sam. Sam, are you on the call today?
I am, yep.
Do you want to ask? You want some clarification, looks like?
Sure. Yeah, that was a fantastic demo. And I think maybe my question was partially addressed in the course of the demo, but I've been struggling. I'm at GitLab, and we're looking to do something very similar to what was just presented for GitLab itself. And I'm struggling to understand the service generated requirement. The way I read it, it kind of could be interpreted potentially two ways. Like one way would be that the actual build service itself would have to generate the provenance. And then potentially another way would be that you could accomplish that through a CI job. And I'm just struggling to understand like what the intent is of that, or maybe if we could get some clarity. I have an example project done on GitLab that uses cosign to sign a build output. But again, I'm not sure if that meets the service generated requirement or not. Like, it kind of implies almost that we would have to embed cosign into the GitLab runner itself in some ways, but maybe that requirement can be met in other ways as well.
So, and others correct me if I'm wrong, I believe the intention of service generated is pretty much to say that the build itself, like the stuff that is user definable, should not have access to the key, right? Because you could do all sorts of bad stuff there. And it becomes, it's hard, right? Because like when you have the builder, right, could be running all sorts of arbitrary code. It becomes hard to know whether or not the, what's actually going on with the key inside of that runner. You compare that with something sort of recording what's going on in the runner and then signing what it recorded. Hey, that's a very clearly defined set of things. The key never ends up in the hands of the developer or somebody, similar. I believe that's in the intention. Somebody feel free to correct me if I'm wrong there.
So if I understand you right, what you're saying is that the service generated has more to do with separation and isolation of the key from the build process than it does with which piece in the tech stack is actually doing the signing. Is that accurate?
Mark?
Yeah, I think so. So for example, and we should probably file an issue about this to kind of like have this and eventually turn it into like actual documentation and clarification, because I agree that it's ambiguous right now. I think, for example, if the signing key is accessible to the actual build script itself, and like someone could have just grabbed the key and generated provenance not using the CI/CD system, that would not meet the requirement. Although I think there's a difference there's some ill-defined difference between 2 and 3 of the non-falsifiability. There's like a stronger bar for 3, but I don't think we've decided exactly what that bar is. If on the other hand, the build script runs cosign and it uses, like GitLab generates an OIDC token, and it does same thing basically as what Ozzer described, but doesn't use the reusable workflows, but still through SigStore and OIDC, we have a guarantee that it really did come from that particular runner. I don't know what others think. I would consider that to meet the requirements, or at least the spirit of the requirement, because you basically can't fake it. We have some guarantee that it did come from the runner.
Might we just rename service generated? Because I think what you were saying, that was the original intent, right? That the build system actually generate the provenance. Correct, Mark?
Yeah, the original intent was that the build system generate the provenance, because I think we didn't foresee these other solutions.
Yeah, and I think it's I think it may be reasonable. I totally agree with what you said, Mark, that the OIDC spiritually really feels to satisfy the motivation behind the constraint. What could be a name that would satisfy sort of both solutions to the underlying sort of purpose?
Do we have an issue to discuss that? Like discuss the naming? If we change the name?
Don't, that's a great idea.
Okay, who's going to make that issue?
Someone who understands it's not me.
I'm happy to take a pass at it if someone would be willing to partner with me on it. That would be
If
helpful.
you could just create the issue and capture it as you see it, then
Sure.
if other people disagree, well, that's the point of an issue discussion. So
Okay. Yeah, I'm happy to open an issue there. It would help us a lot for this to be clarified, because at GitLab, we're trying to understand, do we need the runner to natively be generating all of this provenance? In which case, you know, that's a pretty long roadmap for us to build all of that out natively inside of GitLab versus something like what was demonstrated today with GitHub, right? Are there other paths to accomplish this? Anyway, it has a really big impact on our roadmap. And so we're just trying to figure out, like, what is the actual requirement here? And if we could clarify that in the spec, that would be helpful too.
yeah, I think it's clear to me that the requirement as written isn't really capturing what was intended. Mark, you're really looking for, you can't falsify certain things, if I can just oversimplify. Is that a fair statement?
I think really levels 2 and 3 are a bit ambiguous. Like level 4 is like the top strength, and level 1 is like you basically have anything at all. Level 2 and 3 are meant to be kind of intermediate milestones. At level 3, we say non-falsifiability because we, just based on past experience, you know, sometimes implementations like maybe would, even though it's generated by the service, it uses untrusted inputs. And like at level 3, it's like kind of doing more security work. Whereas at level 2, if you just have anything that's generated by the service, you're kind of moving away from the trust is entirely in the script. So the difference between the two, I think, is ambiguous. And if we have suggestions on how to resolve that or collapse it into one, I don't know.
Yeah, I definitely have some thoughts on that. So once the GitHub issue's up, I can definitely put some, I think there's a lot of also subtlety around, you know, who is actually doing the signing, right? And you know, even saying, hey, I have an OIDC token, great, but that depending on the build script, right? If that build script is not good, it could still sign something that's not, like, it could fake a lot that is still caught by something that sort of exists outside of the builder itself. But I don't want to dive down that rabbit hole right now.
By the way, I am delighted by this overall process of trying to make it happen in a general way. Finding the requirements need some refining the requirements, and we're more likely to have good stuff in the end. So I don't think this is actually an awesome sign.
I agree. That was actually my question for Azra. If they created any issues along their way, they said there were some things that weren't clear, but I digress.
Yes. Yeah. Actually, I would beg that, you know, if there's anything that in the process wasn't clear beyond what you've already noted, I mean, this is exactly perfect for that sort of thing.
Yeah. Okay, cool. Let's try to quickly get through the last couple of items on here. Looks like we'll get an issue out of that. Tom, you're next. We have a salsa blog now. I'm guessing this probably goes to, goes to an issue. We're talking about having a salsa blog, and looks like you're looking for who might approve posts. My quick input on this, Tom, I don't know if you want to drive this, but I don't want to have a crazy process. I think maybe steering committee with a deadline that if we don't review, then it gets automatically published. Lazy consensus, I think, is the word there.
Is there a need for a separate one? We have the OpenSSF has one, and and a lot of people already subscribe to that. We might get more amplification that way.
Yeah, I don't see any reason why we couldn't cross post, but a lot of large projects just have a blog sitting from the main homepage, salsa.dev. Like, for example, salsa.dev/blog. I think would be the idea there.
So I don't know that we care either way. I definitely agree that, like, less process is more, right? Like, you know, basically convince someone that this is well written and not spam, and have them double check your like understanding of Salsa and Go, something like that. I don't know. Please put ideas for how and where to host in the bug.
Cool. Sounds good. Thanks, folks, for taking notes today too. This is great. And then the last topic, Brandon, you brought this up yesterday about having a concerted effort on just collecting open source compromises. I think John Speed might be on the call. I saw him earlier. I know there's been discussion kicking up, and it sounds like we need to bring some folks maybe from the Backstabber's Knife into a chat about this. Anything you want to add there?
I think we kind of like mentioned a couple groups. I think the Backstabber's Knife, Qtel, check marks as well. I think maybe can we either out of band or during this meeting or some other meeting kind of have a discussion on that?
Yeah, John Speed, are you on the call? I thought there was an issue somewhere, or maybe you guys started a Slack discussion.
That's right. There is an issue,
Yeah.
and I can drop it in a second. It will take me a second. It's hard for me to do while I'm talking, but there is an issue, and I think Abhishek now months ago had potentially with Kim listed a set of open source software compromises from over the past year or two. And then there's been a series of conversations where myself and others have said, yeah, this is a good idea. So basically thumbs up from me. And it got so far as there's a private repo created within OSSF called something like OSS-compromises. And myself and Abhishek and a few others have been talking about it. But of course, there are many things going on, but I've kind of been saying thumbs up, and I've been looking for collaborators. So if you're interested in working on such a thing with me, I'm glad to talk about it in the Slack or we can meet. So basically, I'm just saying thumbs up, and we haven't quite had the quorum I was looking for so it wasn't just my own little nerd project.
Okay, cool. Yeah, I think let me share as well. I don't have access to the repo, but we also have one. Maybe we can see how we can consolidate it. This one is public. This was started with Santiago. This was kind of like it's probably not complete, but I think I don't have that larger opinion on where it's hosted as long as it's public. I think that's kind of like the main thing. But yeah, let's sync up offline and discuss it.
Sounds great.
Yeah, and real quick, I suggest proposing this as part of the supply chain working group. I know that's already been mooted because it crosses many things, not just Salsa.
Agreed.
But that said, hopefully this can inform Salsa.
Yeah, that sounds great.
Can someone give me access to that repo?
Well, yeah,
I'll talk to Abhishek. When you and I talk, we'll make sure it happens. I don't know if I have that permission, but if I do, I'll do it. And if not, we'll make it happen.
Awesome. I'll ping you on Slack.
Cool. All right, thank you, everybody. I haven't been checking the chat. I'm not sure if there's anything. Okay, just chatter. But awesome. Well, thanks everyone for the meeting today. This was a great discussion, and looking forward to chatting again next time. Yeah.
Thanks.
Thank you.